Welcome to the Deep Dive, everybody. Today we're going to be checking out a text-to-speech system that's straight out of a sci-fi movie. Like, it can copy voices with insane accuracy, but also create brand new ones, like from scratch.
It's wild.
Yeah. So we've got this academic paper and some info about the massive data set it uses called VoxBox.
Mm-hmm.
But before we jump into the technical details, maybe you could paint a picture for us. What's the problem exactly that this Spark-TTS system is tackling? I mean, we've already got text-to-speech voices, right?
Yeah, you're right. We do. But those existing systems are mostly good at copying voices if you give them some recordings. Spark-TTS, though, is going for something way more ambitious. They want to synthesize completely unique voices, like with the super fine-grained control over every single aspect of the voice.
Okay, I'm definitely intrigued. So how does it actually work?
So at the heart of Spark-TTS, there's this clever thing called BiCodec. Basically, it turns speech into these digital tokens. But here's the trick. It uses two different types of tokens.
Two types. Interesting. What's the difference?
Think of it this way. One type, they call them semantic tokens, captures the meaning of the words. It's like a digital code for language. But the other type, these are called global tokens, is where the really cool stuff happens. They grab the unique characteristics of a voice, like pitch, timbre, the rhythm, all those little things that make one voice sound different from another.
So it's not just about what you're saying, it's also about how you're saying it.
Bingo! BiCodec creates a sort of blueprint of a voice by capturing both the words and that unique vocal fingerprint.
Pretty impressive. But how does it actually do that? Is this where I need like a computer science degree to understand?
No, not at all. It basically boils down to neural networks, those powerful pattern recognition systems everyone's talking about, and some clever tricks for squeezing info efficiently. It's kind of like creating a high-quality zip file, but for a voice.
A voice zip file. I like that. So what's the point of compressing the voice info like that?
Well, for one, it makes the whole system super efficient. In fact, BiCodec achieves state-of-the-art reconstruction quality at a bitrate of just 0.65 kbps.
Okay, I'm going to need you to break that down for me. What does that actually mean in practice? Like if I was listening to an audiobook?
Well, it means that potentially you could download an entire audiobook in just a few seconds, even with a narrator who sounds exactly like, say, Morgan Freeman, if that's your thing.
Now you're talking. That's seriously impressive. So BiCodec handles the voice itself, but what about the words? How does Spark-TTS actually turn text into speech?
Right, that's where the language model comes in. Spark-TTS uses this powerful text-based language model called Qwen 2.5, and this is where things get really interesting.
Okay, I'm listening. How does a language model control stuff like gender, pitch, all those vocal characteristics?
It uses what they call a chain of thought process. Imagine you're planning a trip. You start with this general idea of vacation, then you get a bit more specific, maybe a beach trip, and finally you figure out all the details like flights and hotels and so on.
So you're saying it breaks down the task, kind of like our thought process?
Exactly. In Spark-TTS, you feed the language model some basic labels like male, high pitch, fast speed, and it takes those kind of general descriptions and figures out very precise numerical values, like specific frequencies for pitch or syllables per second for speed.
So it's not just working with vague labels, it's actually quantifying them.
Yeah, exactly. And then using those precise numbers, the model creates those global tokens we were talking about. Those are what shape the unique sound of the voice. And finally, it creates the semantic tokens for the actual word. So it's this really elegant process that goes from simple text and a few attributes to a full-blown unique voice.
That's seriously cool. But you mentioned this huge data set called VoxBox before. Where does that fit into all of this?
VoxBox. That's truly something else. Imagine a data set with like over 100,000 hours of speech, carefully labeled and annotated with every detail you can think of: gender, pitch, speed, even emotional tone.
Wait, 100,000 hours? That's a lot. Where did they even get all that data?
They wanted Spark-TTS to create any kind of voice you could imagine. So they pulled data from a crazy variety of sources: audiobooks, podcasts, even databases made specifically for things like recognizing age and gender from a voice. They really threw everything in the kitchen sink in there.
I'm guessing that variety is key for teaching the system to be so flexible, right?
Absolutely. The diversity of VoxBox is what lets Spark-TTS make such a wide range of voices with like super fine-grained control over every aspect.
And this VoxBox It's open source, right.
Right.
So other researchers can use this huge collection of voice data too.
Exactly. Open source projects like this are super important for pushing the boundaries in this field. It encourages collaboration and speeds up innovation, which is always a good thing.
I love that. So we've got BiCodec breaking down speech into tokens, the language model putting it all back together, and VoxBox powering the whole thing with its huge library of voices. But can we actually hear some examples? I want to get a sense of what Spark-TTS can really do.
For sure. Imagine hearing the same sentence spoken by a guy with a deep voice, then a woman with a really high-pitched voice, and then sped up like someone's in a rush. That's the kind of control we're talking about.
Okay, now I'm really starting to see the potential here. But
Okay.
can it do more than just those basic attributes? Can it fine-tune the more subtle qualities of a voice?
Oh, yeah, absolutely. The researchers, they were able to fine-tune stuff like speaking rate, down to specific syllables per second, even.
Wow, that's amazingly precise. But I gotta ask, nothing's perfect, right? Are there any limits to what Spark-TTS can do?
Well, you're right. Nothing's perfect, and Spark-TTS is still being developed. For example, when it comes to cloning voices, it doesn't quite match the accuracy of some of those more complex systems out there, the multi-stage ones.
Interesting. Why is that? I mean, with all that data and processing power, you'd think it'd be able to make perfect copies.
Well, it's because of the way the language model works.
Mm-hmm.
Remember how it has to predict those precise numerical values for things like pitch and speed? Well, sometimes those predictions can introduce tiny variations, and that can make the cloned voice a little less accurate.
But wouldn't that randomness make it hard to create, like, perfectly consistent clones?
Yeah, that's one of the challenges they're working on. They're looking for ways to improve the system, especially by focusing on timbre control, that subtle color or texture of a voice, you know?
I see. So it's kind of like choosing the right shade of blue when you're painting it can make the whole picture feel different.
Exactly. By getting more control over timbre, they're hoping to improve speaker similarity and make those clone voices sound even more realistic.
Okay, so even though Spark-TTS isn't perfect yet, it's obviously a huge step forward in text-to-speech.
Hmm.
Maybe before we move on, you could quickly sum up the key points so far.
Sure, Spark-TTS is a totally new system that has two main capabilities. Crazy good zero-shot voice cloning, meaning it can copy a voice from a sample without needing tons of training data, and the ability to create totally new, customized voices with like granular control over all sorts of attributes. It's like having a voice synthesizer right at your fingertips.
Well said. This technology could change so much about how we use audio. But I feel like there's some ethical things to think about here too, right?
For sure. With any powerful technology, there's responsibility, and that's something we'll definitely be diving into next.
Welcome back to the deep dive. We just kind of scratched the surface of this Spark-TTS thing, but I think it's time to change gears a bit.
Yeah, you're right. We geeked out on the how, but now I think we should talk about the why. Like, what's the impact going to be, both the good and the bad?
Exactly. I mean, 100,000 hours of voice data, almost perfect cloning. It's cool, but it kind of feels like we're opening a can of worms here. What are some of the upsides you see?
Well, imagine like someone who lost their voice from, say, an illness or something. Spark-TTS could give them back their ability to talk using a synthesized version of their own voice.
That's powerful. And I bet it'd be a game changer for accessibility too. Like, imagine personalized audiobooks for people with, learning disabilities.
Totally. And think about content creators, podcasters, audiobook narrators, you name it. This tech could make production way faster and more accessible for everyone.
Okay, so we've got restoring voices, more access to information. It's starting to sound pretty utopian, actually, but I'm guessing there's another side to this, right?
Yeah, there always is. As this tech gets better and easier to use, well, the chances of it being misused definitely go up.
Yeah, the first thing that pops into my head is deepfakes. I mean, if anyone could just create these super realistic voices, it could be a breeding ground for, like, misinformation and impersonation.
You got it. Imagine getting a voicemail from, like, your spouse asking for your bank info, and it sounds exactly like them. Or political campaigns using fake audio to, try to influence voters. It's a scary thought.
Yeah, that's the malicious side, but what about stuff that's not intentional? Like, what if everyone starts using these synthesized voices? Doesn't that kind of cheapen real human voices?
That's a great question. It makes you think about trust, in a world where you can't really tell what's real and what's fake anymore. Like, how do we know what to believe?
It's like we're heading towards, like, audio skepticism or something, where we have to question everything we hear.
Right, and it's not just casual conversations. Think about legal stuff or important announcements. If anyone can make fake audio that sounds real, what happens to our systems of evidence and trust, you know?
It's kind of overwhelming, to be honest. It's this super powerful tool that could do a lot of good, but it could also cause a lot of chaos.
Mm.
So what can we do? How do we make sure that Spark-TTS and stuff like it is used responsibly?
That's the million-dollar question. There's no easy answer. But I think the first step is education. The more people understand how this technology works, the better they'll be at spotting fakes and protecting themselves.
That makes sense. Knowledge is power, right?
Right.
But knowing about it won't solve everything, will it? What are some safeguards built into the tech itself?
Oh, you're right. Education isn't enough on its own. Actually, researchers are already working on tools that can detect synthetic audio. Those tools could be used by, like, social media companies, news outlets, even law enforcement, you know, to flag content that might be harmful.
I've also heard about, like, putting digital watermarks into synthetic audio, like a kind of fingerprint.
Yeah, that's an interesting idea. It would let you track where the audio came from and check if it's authentic. But of course, anything tech-based can be hacked. So in the end, we really need a culture of, responsible use.
So it's going to be a multi-pronged approach, educating people, building detection tools, and coming up with ethical guidelines for creators and platforms.
Exactly. It's a team effort. Everyone needs to be involved. Researchers, developers, policymakers, and just regular people.
Yeah.
We got to have these conversations about ethics now while the technology is still pretty new.
Well, I'm glad we're talking about it here on the Deep Dive. It's a good reminder that even the coolest, most innovative tech has a responsibility that comes along with it. Spark-TTS has the potential to totally change the way we use audio, but we have to make sure that changes for the better.
I completely agree. We can't just get excited about the cool factor and forget about the bigger picture.
Okay, so we've covered the how and the why of Spark-TTS, but now I want to get into the nitty-gritty. Can we dig a little deeper into the technical side and see how it actually works under the hood?
Absolutely. Let's put our engineer hats on and explore the inner workings of this amazing technology.
Welcome back to the Deep Dive. We've explored the magic and the potential problems of Spark-TTS, but now I'm really curious to see what's going on under the hood.
Yeah, me too. Let's get into the technical details of how this thing actually works.
Okay, cool. Let's start with BiCodec. We talked about how it breaks down speech into these two types of tokens, but can we break that down even further? What's the difference between the semantic and global tokenizers?
Sure. So remember how the semantic tokenizer's job is to capture the meaning of the words. To do that, it uses this super powerful pre-trained model called Wave2Vec 2.0.
Wave2Vec 2.0, okay. This sounds familiar. It's one of those AI models that's learned a ton about language, right?
Exactly. It's been trained on huge amounts of speech data, so it already has a really good understanding of, how language works.
So it's like the semantic tokenizer is already starting with an advantage thanks to Wave2Vec 2.0.
Right. And that lets it encode the meaning of the words into these compact semantic tokens really efficiently. Now, the global tokenizer is a little different. Its job is to capture the unique qualities of a voice. The pitch, the timbre, the rhythm, all that stuff that makes you sound like you.
Right, that vocal fingerprint. But how does it actually pick out those subtle things from a voice?
Well, they use a special kind of neural network. Think of it like a super-powered pattern recognition system that's specifically designed to capture those tiny details that make your voice unique.
So, two different approaches, working together to create a complete blueprint of a voice. And then those quantization techniques come in to compress it all.
Exactly. Vector quantization and finite scalar quantization, they both play a big role in making the system super efficient without losing quality.
I'm starting to get why this technology is such a big deal. It's like they've combined all these different techniques in a really smart way.
It really is. But let's not forget about VoxBox. I mean, we keep talking about this huge data set, 100,000 hours of speech. That's crazy. But I'm curious, how did they even put it together? That seems like a massive undertaking.
Yeah, that's what I was thinking. It's not just recording a bunch of voices, right? There's got to be more to it.
Oh, you're right. It's not just about quantity. It's about quality and diversity, too. So they started by collecting all these open source speech data sets from all over the internet, audiobooks, podcasts, even those specialized databases for age and gender recognition.
So like a real mix of voices. I guess that's what lets Spark-TTS create so many different kinds of voices.
Exactly. But gathering the data was just the first step. They then had to go through and carefully label each recording with information about the speaker, their gender, pitch, speed, even their emotional tone.
Wow, that sounds like it took forever.
Hmm.
But I guess it's super important for training the system to understand the connection between the text and the voice, right?
Oh, yeah. It's a huge job, but it's totally necessary. And to make sure the data was really good, they even cleaned it up, removing any audio that had bad sound quality or transcripts that weren't accurate.
So they really went the extra mile to make sure the data was perfect. It's starting to make sense now why Spark-TTS can do all the things it can do. We've got BiCodec breaking down the speech, the language model putting it back together, and VoxBox providing the fuel for the whole system.
Yeah, it's a pretty incredible feat of engineering, combining cutting-edge AI with, this really carefully curated data.
And the results are mind-blowing. I mean, we've talked about the voice cloning and the super fine control over, all the different attributes. It's like having a voice chameleon or something.
It really is. And the possibilities are like endless. Personalized audiobooks, ultra-realistic virtual assistants. I mean, this tech could totally change how we interact with audio.
Well, everyone, that brings us to the end of our deep dive into Spark-TTS and VoxBox. It's been quite a journey exploring all the technical wizardry, the ethical questions, and, well, the mind-blowing potential of this technology.
I gotta say, I'm excited and a little scared about what the future holds for, synthetic speech.
Me too. But like we said, knowledge is power, right? The more we understand this tech, the better we can deal with its impact on the world.
Totally agree. And for those of you who want to learn more, check out the links to the research paper, the VoxBox dataset, and those amazing audio samples. I mean, hearing is believing after all.
Good point. We'll have all those links on our episode page. Until next time, keep exploring, keep learning, and keep diving deep.